Malthus, his ideas had a revival when Meadows and colleagues published a study called Limits to Growth in 1972, in which they presented simulations of the consequences of exponential growth with finite resources. Their simulation included relations between the world population, food production, industrialization, resource depletion, and pollution. In Callas's words, Limits to Growth inherited the logic of Malthus, with economy taking the place of population and resources that of food. The Limits to Growth simulations are nearly 50 years old by now, and recent analysis by Turner and Alexander presented in The Guardian has matched indices to their prediction. The Limits to Growth baseline business as usual scenario predicted that population overshoots the global carrying capacity and starts to collapse in the next decade unless we would take serious action on controlling our resource consumption. A little over 40 years after the publication, we can assess how well the baseline scenario matches the data so far, leaving aside how to construct and compare indices such as industrial output or service per capita. The figure plots the predicted values in dotted lines together with realized values in bright solid lines. In general, the simulation of the business as usual scenario seems to match the observations rather well so far, with the simulations often being somewhat on the pessimistic side. Yet, the real test of these predictions comes only in a few years, and we should aim to prevent the occurrence of such a collapse on global scale. Perhaps the most famous critique on the limits to growth came from the Nobel laureate for growth models, Robert Solow. In his 1973 article, Is the End of the World at Hand?, Solow wrote, "There is at least one reason for believing that the doomsday story is almost certainly wrong. The most glaring defect of the Forrester-Meadows models is the absence of any sort of functioning price system. I am no believer that the market is always right, and I'm certainly no advocate of laissez-faire where the environment is concerned. But the price system is, after all, the main social institution involved by capitalist economies, and to an increasing extent socialist economies too, for registering and reacting to relative scarcity. There are several ways that the working of the price system will push our society into faster and more systematic increases in the productivity of natural resources." On page 47, Solow explains, "Higher and rising prices of exhaustible resources lead competing producers to substitute other materials that are more plentiful and therefore cheaper. To the extent that it is impossible to design around or find substitutes for expensive resources, the prices that contain a lot of them will rise relative to the prices of other goods and services that don't use up a lot of resources. Consumers will be driven to buy fewer resource-intensive goods and more of other things. All of these effects work automatically to increase the productivity of natural resources, i.e., to reduce resource requirements per unit of GDP. The deforestation of Easter Island certainly is not an isolated case. For Madagascar, estimates of deforestation range from bad to worse, and between 50% and 90% estimates, there is mostly disagreement on the original forest cover. Conservation International estimates that only 5% of original forest cover remains on New Caledonia, and on Mauritius it may be as little as less than 2%. I talk about these islands first, as islands often serve as a useful metaphor for global development. The Food and Agriculture Organization of the United Nations monitors global forest cover and reports their assessments with 5-year intervals since 1990. Between 1990 and 2015, the global forest cover has been reduced with an area larger than the size of South Africa, or about 3 times larger than California, or about 14 soccer fields per minute. As Pim and Reeve point out, worse however, Myers et al. Show that the cookie cutter is not random, it is malevolent. In the 17 tropical forest areas designated as biodiversity hotspots, only 12% of the original primary vegetation remains, compared with about 50% for tropical forest as a whole. Even within those hotspots, the areas richest in endemic plant species, species that are found there and only there, have proportionately the least remaining vegetation and the smallest areas currently protected. Fortunately, the vastness of largely unspoiled habitats that one can still find on Earth is magnificent, perhaps so much so that one could be tempted to disregard or maybe even distrust statements like the 14 soccer fields per minute statistic. The same statistic presented in another way, a decrease in the global forest cover from 31.6 to 30.6% may seem more credible and deceptively less alarming. You may have wondered why the Easter Islanders did not take measures to protect their natural resources at some point. Brander and Taylor offer the following explanation. It is even possible that individual Easter Islanders did not recognize that depletion was taking place. Although the forest disappeared rapidly by archaeological standards, change was slow over the course of an individual lifespan. Typical lifespans for those who survived infancy would have been in the order of 30 years. And even during the most rapid depletion, the forest stock would have declined by no more than 5% over a typical lifetime. Many of you have already recognized the parallels with climate change, where the 40% increase in the atmospheric concentration of carbon dioxide over the few generations since the Industrial Revolution may not seem enormous from the perspective of any individual generation, but this change is epic by geological standards. The human impact on the concentration of greenhouse gases is exemplary for a much larger set of influences over natural processes. Recently, part of the scientific community started adopting the term Anthropocene to describe a new geological epoch during which human activity has a measurable global impact. Crutzen introduced the term by referring to our impact on land use, the prevalence of river diversion, and the share of the fish stock used for human consumption, among others. The realization that humanity has a globally measurable and increasing impact inspired the latest influential contribution in the Malthusian tradition by Rockström and colleagues. Rockström et al. Proposed to establish 9 planetary boundaries for the impact of our economic activity and suggest parameter values for 7. For example, the proposed threshold for climate change is set at an atmospheric carbon dioxide concentration of 350 parts per million. Currently, and ever since 2016, it is well over 400. The current rate of biodiversity loss and disturbances to the nitrogen cycle are also thought to be outside of safe boundaries. Johan Rockström, by the way, is an honorary professor here at the University of Amsterdam. The idea that every environment can only sustain a population of a certain size implies that we face some level of absolute scarcity. Yet, there is no reason for this carrying capacity to be fixed over time. Economic development through education and technological progress can increase global carrying capacity, while imprudent resource consumption, like the consumption of trees on Easter Island, can deteriorate carrying capacity. To illustrate the point that the carrying capacity is conditional on behavior further, take the example from the documentary film Cowspiracy.
The human population drinks 5.2 billion gallons of water every day and eats 21 billion pounds of food. But just the world's 1.5 billion cows alone drink 45 billion gallons of water every day and eat 135 billion pounds of food. This isn't so much a human population issue, it's a human eating animals population issue.
The notion of absolute scarcity is at odds with how neoclassical economics treats scarcity. In neoclassical economics, the largest school of thought within economics today, resources are assumed to be scarce relative to one another. That is, one can substitute one scarce resource for another less scarce resource. This view on scarcity has led to many insights. Various will be discussed in the coming weeks. And for long, this assumption seemed harmless because it was inconceivable that human consumption could have a global influence. However, a widespread modeling assumption of constant returns to scale amounts to assuming that there is no scarce, non-augmentable resource like land, as Solov reminds us. Now, land may actually not be the best example of a non-augmentable resource, as we have augmented the amount of available land in our cities by building upward. Yet, there are non-augmentable, exhaustible, and or non-renewable resources that are absolutely scarce in nature and relevant to production processes. With the arrival of the Anthropocene, it is becoming increasingly dangerous to ignore that we face absolute scarcity. I have hardly given attention to Kallis' his critiques, while some are worth mentioning. For example, Kallis reminds us that the limit resides in the subject and the intention, and not in nature, which is indifferent to our intentions. And it is our intentions that should be limited.